Okay, I'm going to start with chapter 2. Break this up into two parts. So this will just be the part 1 of 2 for this chapter. Okay, so overview of the topics in this chapter. We're going to look at some common program elements. So some of the elements that essentially every C++ program uses, in addition to elements that are used pretty much in all C++ programs. Okay, going to look at C++ operators. In this case, operators are essentially just symbols that are used to perform some kind of operation, whether it be a math operation or a logical operation, for example, such as this and that, or this or that, or not this. Okay, meaning logical operations, which we'll take a look at further on. Okay, then standard input output. This is just what it says is how do we, as users writing these so-called console applications, how do we get information into our computer or into our program, and how do we have information output from our program? And standard input and output is just essentially come from the keyboard is our input, and our output is to the display. We're going to look at standard libraries, and libraries essentially are is a, a block or a structure of code that performs certain operations for us. Okay, so it could be something like performing a math function such as like doing a sine or a cosine or maybe an absolute value. Maybe we want to perform some operations on characters. Okay, there's functions for that, and we'll take a look at some of them. Common debugging tools. These are debugging mean that, let's say your program has a problem, which is a common thing for us when we're writing code, and you're trying to figure out what's wrong with it. So debugging is basically that process of doing that. And there are tools available in all the integrated development environments, although I'm going to use Visual Studio Community to help you to figure out where the problem is, essentially. Okay, just history. Bjorn Strupp in '79 developed it, and it runs on a variety of platforms. Okay, so pretty much, it could be platform independent. Okay, which operating system it's it runs on. Okay. Okay, so here are some basic elements, and what I'll do is I'll go through and open up Visual Studio and kind of work at it at the same time so you can see these in action as I go through this. Okay. So first one is just comments. So this is code you put in your program that would be just for another program, such as yourself or someone else. It really is independent. It doesn't have any impact on how the code executes. Okay. There's another thing called preprocessor directives. Okay. Now, what these are is they're just statements that are used to tell the preprocessor to do something prior to creating the executable code. Okay. And what you're going to see is that hashtag or pound sign, or whatever you want to call it, that will be in the front of any of the words that are preprocessor directives. Then we have the using directive. The using directive we're going to use using namespace std, and what that does is it's going to help us with for so-called name resolution, right? Which I'll talk a little bit more about later. Code block. Code block is essentially just going to be where do I put my code, right? And it's going to, the first part of this is where do you put your code? And the second part of this is if we want to group code, okay? So we'll look at that too, all right? We have to follow this. Constants and variables. So there's things inside your program. It might be, let's say you're performing a math operation and you're doing something with pi, right? So pi is a constant. Pi would be something that you don't want ever to change. A variable might be if you're doing, let's say, the area of a circle. It'd be pi times pi times the radius squared. The radius would be something maybe that you allow the user to enter, and that could change. So that would be defined as a variable. And a constant would be, let's say, pi. Okay. Data types. In chapter 1, we took a look at a little bit at this idea of data types. But what you can recognize is that numbers can be stored as we could work with numbers that are negative, positive. We can work with numbers that have fractional part, right? We can work with characters and from the ASCII table. So things like a word processor needs to work with characters. So we need to be able to do that too. Okay. And the last part is identifiers. Okay. And this is basically says, how do I name? Part of it is, or at least the first part of it will be, how do I name my variables, right? And what are the rules around that? How you can name those, okay? And there's some other things like constants also. How do you name your constants? And also a thing called a function. We also need to follow some rules with that, okay? Okay, comments. Comments are just for readability, okay? So that's one of the things is when we write code, we want it to function. But we also want it so that if you look at it later on, you can kind of figure out what it does. Okay. And that one of the things you use is you put some information in there that just essentially gives you a little bit more detail on different components of your program. And you do that with comments. Okay. Comments are ignored by the compiler, meaning that they don't get added to your program. They have nothing to do with your program in terms of its execution, how it runs. Okay. And we're going to look at two different types of comments. We have the single line comments and we have the limited comments. Okay. So what I'll do now is I'll open up Visual Studio and just create a small program so I can go in and show you each of these concepts as we go through. Okay. Create a new project. And it's a console app, right? So it's just like a text application. And next. Okay, this is where I'll name it. I'll say, EGR 230 underscore, and I'll say chapter 2 sample code. I don't know. How about that? That looks good. Okay, then I'll do create. Oh, and don't put it here. Before you do create, put it on your desktop. It's much easier to find and work with. At least that's my recommendation. Otherwise, we have to drill down and figure out where it is. So just say create. Okay. And here it is opening up. Okay. So what you can see here is, I don't care about that. Okay. Let me make this a little bit larger. You can actually see it. Here we go. So this is what it looks like essentially when you first open it up. Now what you're going to notice here is that there are, let me just expand this out. There are lines of code that are green. These are all comments. So Visual Studio recognizes their comments and makes them in green. So you see the // everything else on this line is just a comment. Okay. And this is just, there's nothing on this line. And everything else down here is comments also. Okay. So let me just get rid of this. And I'm going to go up here and I'll add another comment. So let's say that you had it on multiple lines. You did / star to start it. And by default, Visual Studio actually brings you out the ending delimiter. Okay. So this is sample code, let's say. Okay. So anything between, this is my opening delimiter essentially, / star, between the, / asterisk, let's say asterisk, /. Anything in between here is treated as a comment. So it has no impact whatsoever on the execution of this code. So if I go and run it, oh, let me put one more other thing in here. I'm going to do system, pause, and let me do it like that. Okay, so I'm just going to do run. And there it is, hello world. Okay. if you can see it. Let me see if I can make this a little larger. Properties. Okay. Hello world. Okay, so there's hello world. Uh, and that's essentially it for that, right? And the comments that I put in there had no impact on this. Okay, so those are the two ways to do comments: // everything else in the line is part of it. And if you want multi-line comments, you do it like this. Okay. All right, so I'll just close this. Okay, so that's comments. Next, preprocessor directives. Okay, and this is an example of one. There's actually one in the code here. Let me. Okay, so this is a preprocessor directive. So what I do is I'm going to just put comments in here to explain this. This is just means go out and get this file and add it to your program. And as we go in code, we write code for our programs, what we're going to find is that certain functions or certain pieces of code from libraries, there's some information inside of these files that are needed for them to be able to execute. Okay, so this really just says include IOStream, and IOStream is an actual file that'll get included in your program just before it gets translated over into executable code. Okay, or compiled, then translated over to executable code. So this is something that's going to be given, right? So as part of this, in this course, each time it's going to say, if you're going to use some functions or some keywords down here, you're going to need to include one of these, and it'll be defined which one you need. Okay, so this just says include this file IOStream. I'll just say file IOStream in your program. Okay, and I'll just save it. Okay, could actually put 200%. Oh, that's okay. Okay, so continue on. All right, so that's all that is. Just the let's push it down for here for now. Okay. The next thing is the using directive. Okay, this is the one we're going to use. So in this class, you're going to need to use this essentially in all your programs. All right. Although, if you look at this program, it's not included in it, and it works. But the reason is because this basically says here that cout is defined in this library called std. All right. So if we get rid of this part, and you'll see it red tilde, not red tilde, red squiggly line underneath the word, because it doesn't know anything about this thing called cout. All right. Well, to solve that, we're just going to do using name space std. Okay. So now what we're saying is anytime we have keywords or functions or objects is what these are called. Some of them are called. Is that they're supposed to look in the standard library to execute them or use the version that's in this thing, std library. And the reason is that, as code is developed in different parts of the world, if you didn't, other people maybe use different, the key point would be that if you develop some code for the, base C++, or libraries for the base C++, you would put them in a library, and you would define that library so that you would do the same thing here. You might be using namespace and then whatever the name of your library is. Okay. For us, all we really need to know is use this in all your code, and you'll be good in terms of, resolving the names to this library. Okay. So these two lines of code are going to be used in every single, these two lines are going to be used in every single program that we write, essentially. Okay. The next thing, of course, is integer main. Here's my closing brace, and here's my, I'm sorry, opening brace, and here's my closing brace. And all our code essentially that we write goes in between here. The only thing that doesn't go here are these additional things like our includes and our namespace, and then some other things that we might use, some other preprocessor directives. And even sometimes when we define some variables or constants, we'll use this also. We'll put them up here, okay? But everything else has got to go down in here, right? Okay, next. Okay, here's the name of the standard C++ namespace. Okay, code block. Okay, so code block is basically it really means grouping all this code together. Where we're going to see this mostly is in when we do like main, when we do function, what's called functions, and where we initially see this is in main. Okay, so here's my beginning. Notice the direction. That's my opening brace for my code block, and then my closing brace. Okay, and this is all part of this thing into main, which I'll talk about more as we go along. But what you have to recognize is that when you run a program, this is some what they call preamble, some additional information up here. Everything's preamble. What additional information for your program? Execution actually starts right after this opening brace in the main function, what's called the main function. Okay, so every program, C++, has to have this thing, main. All right, this part is what we define. For now, just it's an integer type, which means something about the information that it passes back to the operating system. But for now, all we need to know is you need this in your program, okay, to start. Then you write your code, and then you have a closing brace. Oh, the other part I do here is I add this system pause, because depending upon how you run your program, you need to have it pause at the end, okay? And this may or may not be required, when you, depending upon which development environment you use, okay? But I just put it in. It's not going to hurt, okay? But it just basically says system means like basically go to the operating system and execute this thing called pause. And what does it do? It just waits until I hit a key to continue. Okay? All right. Constants and variables. Okay. So just some terminology here. And what we're going to see is that we call this thing a literal constant. So let's say you set x equal to 5. The 5 is considered to be a literal constant, okay? This means you actually just, you type it in directly, that number or that string. You could put a string like this, except we won't talk about how you do this until a little bit later in the class. You could put a character in or numbers. These are just some examples. And those are things that they say cannot be modified, but it should make sense that, yeah, this number cannot be modified, but the variable can be modified, okay? So just terminology, when you actually type it into your program, an exact number, it's just called a literal constant, okay? A variable can be modified, and we're to use these quite extensively. So like here's a line of code. It says integer x. What it means is create this variable called x and make it an integer type, okay? Integer type just being it's a whole number, okay? As we saw back in chapter 1 when we worked with numbers, some had fractional parts and some were whole numbers. Integer is a whole number, all right? And it actually can do positive or negative numbers, all right? So an extension from this is you can actually go create a variable, in this case, or declare a variable, set it to a value, so initialize it, and set its data type. So the structure is always going to be data type, integer, character, float, double, variable name, and this part is kind of optional. You could put this in or not. Sometimes you need to do it. You need to initialize a variable at the same time as you declare it. Often you don't need to do that, okay? But this just says, okay, for the program, it's going to create location in memory somewhere, and you don't need to know where that location is, but it does. And then it stores a 5 in it. And then how it's interpreted, it's going to think whatever binary number equivalent to a 5 is stored in that location, and it interprets it at an integer, as an integer. Okay, and the reason is of course it could be a character, or it could be a number that has a fractional part or float data type. So it needs to know what type it is. And we'll look at some as we go along. We'll look at different numbers and how they're actually stored in memory. Okay. So more. Uh, so those are just considered to be like declaration statements. Okay. And here's some more examples of that. And I'll put some in the code to show you that. So in the source code, we have, here's my program, just says hello world. What I can also do here, and recognize this C out and the redirection operators basically just says hello, send hello world to the display. That's all this line does. And the one other piece of this, it does \n, which basically means go to a new line. If you didn't put this \n in here, it would just say pause right after this word. So it gives us a new line on the display. All right. So let me go here, and I'm going to do integer x equals 5. All right. And then I'll go to here, and I'll do cout x. And I'll do this thing called end L, end line. So I'm going to put a comment in here. End L is the same as this \n. Both mean new line and display when displayed. Okay. Or how about I say on display or through display? Through display. Oh, there we go. Through display. Just comment. Really doesn't matter what I say here. Okay. So both of those will work the same. So let's go run it. Oh, it's running right now. So let me run it. And there it is. There's 5 and there's hello world. One of the things you'll notice is that when I did cout and it just said like the variable name. So whatever I call this, I could call this x1 and this would be x1, right? I could do that if I wanted to. I could even call it XYZ, although XYZ doesn't have a lot of significance for a variable name. I could still do that. It's perfectly fine. It works. So if you run it again, you'll see. Okay. Now, of course, if you wanted to display the letters X, Y, and Z, just put double quotes around it. You run it. There it is, X, Y, Z. Okay. So we got that. And these are different ways. And what this is, these are different declaration statements and initializations. You can actually initialize it this way too. It's a little bit different. You could actually say like this, the name of the variable, paren, and then the value, and then close paren. Okay. So that's another way you can go and set it. And the same thing down here. All right. Now there's one other thing is that we have this thing called a constant. And there's my 0. I don't know what font I'm using here. It says constant, integer, and then the name of the variable. So it's got this extra thing, const, which is constant, and minimum size, and set it equal to 0. And all that does is, like if I said, I put it over here. Let's say I'm going to call this const int. Let's say pi equals 3.1415. I don't know, something like that. Now what happens if in my code, if I tried to change pi, make it something else, it would fail. Okay, but that's how you would write, like if you had something as a constant, and you would just use the you would create. This is my identifier that I defined, pi, and constant is a keyword. You can see them in blue. Integer also, so it's constant integer. Oh, you know what? I can't do it like that. It should be not constant integer. It should be constant double. Okay. Because the reason is because it's not an integer. It's a floating point number. Otherwise, if I did constant integer pi, it would truncate everything and it would only display 3. Okay. So we have to make sure you use the correct data type. Okay. So we'll see more of this and we'll take a look at some examples after. Okay. The next thing is data types. All right. And these are the common ones that we're going to use. Um, Integer, float, double, character, boolean. And you saw me use integer, you saw me use double there, and there's also character boolean, meaning just can be true or false. So different ways to store data. Um, and in this language, in C++, you have to explicitly state, how that data is going to be stored. In other languages, you don't need to do that. But you've seen an example where I used integer and double. I could also use, like character. So I can do char, let's say letter equals first colon, let's say s, like that. Okay. So now what it does is it takes the ASCII equivalent, which you don't need to know what it is, but it's not that you don't need to know what it is, but in order to write the code, you don't need to know what it is, right? It's just going to take whatever the ASCII equivalent of s is and store it in a variable called letter. And the way it's going to store the data is as a character. Okay? So that's how you would use, there's another one, this is character data type. Okay. Okay, so there's rules when you create identifiers. Okay. The naming. You saw how I did like X or I did letter. It's got to begin with a letter underscore. You can't put a number first. Okay. Alphanumeric characters and underscore characters only. So you could use numbers also as part of your word. Can't be a reserved word, so it can't be like character, integer, double, whatever, constant, those kinds of things. Okay, and only the first 31 characters are used to identify it. I'll tell you, 31 characters is a long name, and we won't be using anything that nearly that long. Okay, and the other thing is that what you'll see is as we go and write the code, the identifiers also should be meaningful. They should have a meaningful name. Oh, last part here is it's case sensitive. Okay, so pay attention to that. Meaning that if you had a variable, like let's say letter, and I came along here, letter, those are two entirely different variables. Okay, now I have the same one, just overwriting it. It seems to allow me to do that. But recognize that if any of these characters are different, meaning upper or lowercase, in this variable, these are two different variables. Okay. What we'll do is we're going to follow the standard. So I'm just going to delete this one. We're going to follow the standard where that we use just like lowercases. Well, not lowercase. Camel notation is what it's called. But lowercase, all our variables are going to start with lowercase. Okay. But even my naming for this particular, this identifier, this variable, letter, you can understand, or at least get it from that name, what it is or could be. Okay. All right. So we'll as we go through, we'll talk more about it. But for now, here's my constant double pi. So this is something, essentially this is not a variable, but a value that I don't want to change. This is a variable. This one letter can change, can contain something different than s. Here's another one, xyz, which doesn't have, that's not a very good naming convention, right? And that's 5. And here's a cout statement. Here's another cout, and then system pause. Okay. Right. Okay. So I'll leave the rest, the C++ operators for part 2, okay, of this section. But for now, we started off with some basics in a basic program, so you can see some of the typical elements that we'll use. We're going to use variables quite often. We're going to do cout, and we're going to do another thing called cin, which you'll see shortly. Okay, but this is a very, very basic program. In fact, like everything here, these first three are really not even used in this code right now, right? So let me just go back to what I had originally, right? X, and then this was a variable, X. And save it, and then you can run it and see it. But all it does is essentially declare variable X, set it equal to 5, display the contents of variable X, and then display this message, hello world. Okay? And there it is. And that's it for now.